Hello and welcome back. Today we are going to continue what we're learning about with slope and using that to prove, to use similar triangles to prove that two parts of a line have the same slope. Alright, so our objective for today is I'll be able to use similar triangles to prove same slopes. Alright, so in order for two geometric shapes to be similar, the shapes must have the same angle measurements and the sides must be proportional. So let's take a look at an example of that. Alright, so here are two triangles. We have triangle A and we have triangle B. Alright, and triangle A looks smaller than triangle B, but we'll find out that they are similar. Alright, so the first thing that I need us to do is, as you're drawing this, I need to make sure that you're labeling triangle A and B, and then with capital letters, and then we're going to label each angle with a letter as well, with a lowercase letter. Alright, so A, B, C, D, E, and F. Alright, this will just help us when we reference back to it to prove why these two are similar triangles. Alright, so let's take a look. So what we want to make sure is when we're comparing, we're going to start with angles. When we're comparing our angles, we're going to pick one. So let's just start with triangle A, and we're going to start with angle A. So angle A, is it similar to angle D? Because we're going to look at the same spot on the different triangle. And we know that they're congruent, we know that they're same because of this right here. There's one line, which means that they are the same. So angle A is congruent or the same, and that's the symbol that we use, is the same as angle D in triangle B. Alright, let's take a look at B. We know that that little box right there means that they're both right triangles. So angle B is the same as angle C. Alright, and the same thing, let's look at C and F. They have two slash marks, and the reason why there's two is because they're not the same measurement as angle A was, but they are the same as C and F are the same, but C is not the same as A, and F is not the same as D. Right, so angle C is congruent to angle F. Alright, and this should be an E, not a C. Alright, so far so good. We know that the angles are the same, so we're halfway there to figure out if these figures are similar. Alright, so let's take a look to see if these side lengths are proportional. So how we're going to do that is we're going to take line AB over C or DE, DC. Alright, so AB, this angle measurement or side length right here, over DC, because we're just comparing it, it's a ratio, 3 to 4, alright, and we're going to see if it's equal to the second triangle. So the same thing, D to E over E to F. Alright, so AB, we know that the feet or the angle measurement is 3 feet to 4 feet. And we want to know, is it congruent? Is it the same as 6 feet to 8 feet? Alright, so we're going to cross multiply. You could also see, ask yourselves, are these congruent by seeing if they are just reduced fractions of each other? But I really like to cross multiply. So 3 times 4 is 24. And is that equal to 4 times 6? It is. So because they are the same, because they are congruent, that means that these are similar triangles. Similar triangles. Yes, they are. Alright, so let's take a look at, since we know what a similar triangle means, how can we use similar triangles to prove that their slope is the same? Alright, so let's take a look at this example. So line AE, so line A, which is right here, AE, this is the line. Line AE is drawn on the coordinate plane. Alright, we know this. Triangle ABC is similar to triangle CDE. So ABC, CDE. These triangles are similar, which means they have same angle measurements and they have proportional side lengths. Alright, we want to use similar triangles to prove the slope AC is the same as the slope of CE. So AC is the same slope as CE. Alright, so in order to prove that the slopes are the same, you must show the vertical change of AE is proportional to the vertical change over horizontal change of AE is proportional to the vertical change over horizontal change of CE. All right, so essentially we are finding the change in y over change of x of line AC and the change of y over the change of x in CE. All right, so let's take a look at this. So the first thing that we want to do is we want to compare. We want to find the coordinates of point A, which I gave you already, but if you looked at right here, you would see that you go over 4 and up 3. So A is at 0.43, and the coordinates of C are at 8, 6. All right, so in order to find the slope of these 2 points, we already know how to do this, but we want to try to find the change in y over the change of x. All right, so the change of y is 3 minus 8. Oops, I don't know where I got the, man, oh man. We want 6 minus 3. All right, so let's erase this. I apologize. Try again. All right, so we have the change in y over the change in x. We have 6 minus 3 over 8 minus 4. All right, so 6 minus 3 is 3, 8 minus 4 is 4. So the slope of this line right here is 3/4. And we're going to do the same exact thing. The coordinates of plane C and the coordinates of plane E, which is the change of y over the change in x. All right, so change in y, y2 minus y1, so 12 minus 6 over 16 minus 8. All right, 12 minus 6 is 6. 16 minus 8 is 8. When we reduce 6 8s, we get 3/4. Now we ask ourselves, is 3/4 and 3/4 the same number? Yes, they are. So because they're the same number, because they're proportionate, and because they equal the same fractions, similar fractions, they have the same slope. So we just use triangles to prove that these slopes are the same because we found these 2 points. We know that if they're similar triangles or lay on the same line, they're going to have the same slope. All right, so if you have any questions, or please write those down. If not, ask 2 questions about the material, and we will talk about them and get back to them when I see you next in class. I hope you have a great night, and I'll see you later.